Hi everybody. Today we are going to discuss numericals in kinematics based on equations of motion. Based on equations of motion. Do you remember? There are 4 plus 1, 5 equations of motion. One is v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, and Sn equal to u plus a into n minus half, and s equal to v plus u by 2 into t. So I gave a worksheet on the previous video, right? First you complete that, then only you see this video, please. It's my humble request. First complete that worksheet and see this video, right? Yeah, let us see the numericals one by one. Yeah, see, this is the question. An athlete takes 2 seconds to reach his maximum speed of 18 km per hour. So what is the magnitude of average acceleration? So athlete means a runner. He takes 2 seconds time. So here what is given, sir? Time is given as 2 seconds to reach his maximum speed 18 km per hour. So maximum speed means from where? From 0. That means initial speed is 0. Then the final speed is 18 km per hour. So we need to convert this into meters per second. You know that 18 into 5 by 18, that is how much, sir? 5 meters per second. So that we need to calculate what? Acceleration. Now this is the given data. Okay, so first you read the problem and write given data properly. Then half of the problem is done. Now acceleration is equal to, what is the formula? V minus u by t. Then substitute that, that is 5 minus 0 by t is 2, that is 5 by 2, that is how much? 2.5 meters per second is the average acceleration of the athlete. Understood? So the given data is not in same system of units. See, it is in kilometer per hour, it is in second. That's why I have converted this. Understood? This is the first one. You now see the second question. A person traveling at 43.2 km per hour applies brakes, giving a deceleration of 6 meters per second square to his scooter. How far will it travel before stopping? Okay, this is the question. So you pause the video and take the question and try to solve by it your own self. Okay, just you pause the video and take the question and try to solve it. If you did not get the answer, or if you want to verify the answer, or if you have any doubt, then you continue watching the solution. Clear? Yeah. Now see that here what is given? It is initial velocity is given. How much? 43.2 km per hour. How much, sir? That is 43.2 km per hour. If you convert this into meter per second, 43.2 into 5 by 18, that is 12 meters per second is the initial velocity. And before stopping means final velocity is how much? 0. Okay, na? So final velocity is 0. Next, what is given? Deceleration is given. That means a is equal to minus 6 meters per second square. It is deceleration. Next, what? How far will it travel? How far means what? Is it distance or time? Okay, how far means it is the distance. Remember that. How long means time. How long means you need to calculate time. Okay, how far means you need to calculate distance. Remember these two. Okay, now this is the thing. Now see that what is given? U, V, A, S. Okay, is there any formula connecting V, U, A, S? Right, so that is V square minus U square is equal to 2AS. This is the formula. Yes or no? Very good. Now substitute that. V square is 0. Okay, V square is how much? 0 square is 0 minus U square. U is 12 square, that is 144 is equal to 2AS. 2 into A is how much? Minus 6 into, yes, we need to calculate that. Right, this is minus 144 is equal to minus 12s. Therefore, s will be how much? 12 meter. This is the answer. So he travels 12 meters before stopping. Understood, Nana? So you remember this. How long means you need to calculate time. How far means you need to calculate distance. Clear? Right. Now see the third question. A train starts from rest and moves with a constant acceleration of 2 meter per second square for half a minute. Okay? The brakes are applied. Then the train comes to rest in 1 minute. This is the question. Okay? Then what we need to calculate? Total distance traveled by the train and the maximum speed attained by the train and the positions of the train at half of the maximum speed. Okay? So let us see this solution. Okay? Right. Read the question properly before going to answer it. Now I am doing its solution here. See that a train starts from rest is given so that its initial velocity is equal to 0. Means here the train starts from point A with a constant acceleration of 2 meter per second square. Acceleration, let us take 2 meter per second square. How far? For half a minute up to B. Okay, that means 30 seconds. From point A to B, the body accelerates. Right, Nana? Next, then the brakes are applied. At point B, the brakes are applied. When brakes are applied, what happens? It decelerates and comes to rest at point C. Here, velocity, let us take 0. Right, Nana? Right. How much time it takes here? It takes 1 minute, means 60 seconds. Clear? Then what do you need to calculate? First, total distance traveled by the body. Means AB plus BC you need to calculate. Understood? Right. Here at A, the speed of the train is 0. As it is accelerating for 30 seconds, it attains a speed something, let us take V1 at B. Okay, so it is accelerating till B. From B it is decelerating. Okay, up to A its speed increases. Okay, now from B its speed decreases. Means what is the maximum speed of the train? V1 is the maximum speed. Understood, Nana? Alright, now first let us calculate total distance. Let us take AB as S1, BC as S2. Okay, AB as S1 and BC as S2. Now first calculate the distance S1. Okay, so what is the formula? S1 is equal to ut plus half at square, because we know S, U, A and T. It is accelerated motion. That is equal to U into T. 0 into 2 is 0. Then half into acceleration. 2 into T square. 30 square is 900. So that it is how much? 900 meters. So the distance between A and B is how much, Nana? 900 meter. Okay. Now I want to calculate what? S2. This distance. So I want to calculate S2. How can I calculate S2? I have final velocity, time. Okay. There is no retardation. Retardation is not given. Yes or no? First we want to calculate retardation. For that what we are going to do? First you calculate V1. How much is V1? V1 is equal to U plus AT. U plus AT. That means the final velocity of the first part we are going to calculate. V1 is equal to U plus AT. That is U is 0 plus A is 2 into T is how much? 30 seconds. Okay. That is how much, Nana? 60 meters per second. This is the maximum speed attained by the body. Already B is answered. Okay. What is the maximum speed attained by the body? 60 meters per second. Okay. Now we want to calculate deceleration for this case. Okay. How? V is equal to U plus AT. That means V1 is equal to, V is equal to V1 plus AT. This is V, this is U for the case. Now 0 is equal to V1, 60 plus A, we don't know for this case. Okay. Into T is how much? 60. Therefore, from this what do you get? A is equal to minus 1 meter per second square you will be getting. Understood? So for the second case, what is the acceleration? -1 meter per second square. v1 is how much? 60 meters per second. We have calculated that. Now let us calculate the total distance s2. So s2 is equal to how much? Ut plus half ad square. Ut plus half a t square. Now which is u for BC? v1 is the u. Understood? v1 is the final velocity for AB part. Same v1 is the initial velocity for BC part. Okay, very good. Then 60 into t time 60 plus half into a is -1, so minus half into t square, 60 square, how much? 3600. So if you simplify this, 3600 minus 1800, so how much, sir? 1800 meters is BC, S2. Now therefore what is the total distance? S is equal to S1 plus S2, that is 1800 plus 900, how much, Nana? 2700 meters, or you can write this as a 2.7 kilometers also. Got it? So in this way one can calculate the total distance. Clear? Now A completed, B also completed. What is the maximum speed? 60. Now see that the positions of the train at half of the maximum speed. What is the maximum speed? 60. Half means 30. That means at 30 meter per second, where is the body? Means what is the position of the body? Two positions can be possible. When it is accelerating from 0 to 60, it may have some 30 somewhere. Okay. Again from 60 to 0, it may have somewhere at 30. Okay. So two positions are possible. First let us calculate this position from A to B. Where is the body at 30 meters per second? Now final velocity, let us take 30 meters per second. What is the initial velocity? 0. Okay. Now what we need to calculate? Acceleration is 2 meter per second square. Position we need to calculate. Okay. Yes. So v square minus u square is equal to 2as. Okay now. So from this formula we will get s value how much? V square means 30 square 900 minus u square 0 by 2a means 4. Okay. How much is this? 900 by 4. You simplify this, then it is a 225 meter. Means from the starting point at 225 meters. Okay now, at 225 meters its speed is half. Right. Next, here also it is possible 30, because from 60 it is going to 0. Now that position let us calculate from point B. Same again, v square minus u square is equal to s. V square means what here? 30 square. Okay. 900 minus u square is 60 here. This is u, this is v. Okay. 60 square u v. 60 square how much? 3600 by 2 into a minus 2 equal to s. Okay. Now you simplify this. How much is this? 2700 by 2. Yes or no? 2700 by 2. Now this is how much? Okay. 1350 meters. From where? From point B. It is at 1350 meters. Its velocity is half. Then from A how much? From point A. From B it is 1350. From A, what is A to B? A to B 900. Therefore 1350 plus 900. How much? 1350 plus 900. 50 to 2250. Okay na? So one is 225 meter. Second one is 2250 meters. At these two positions. At these two positions, what is the velocity of the body? 30 and 30. Understood? Very good. In this way we can solve this kind of problems also. Clear? Yeah, let us see next one. Now see question number 4. It is given that a bullet traveling with a velocity of 16 meter per second penetrates a tree trunk and comes to rest in 0.4 meters. Means after traveling 0.4 meters, it comes to rest. Find the time taken during the retardation. Okay, means let us take this a trunk of a tree. So before hitting the tree, its velocity is how much? Let us take that as 16 meters per second. So after penetrating through this, here it comes to rest. Here what is the velocity? 0. Means it enters into the trunk and comes to rest. When it is entering it, the tree trunk offers some retardation. Okay, na sir? That let us take something A. Now, how much distance it has traveled in the tree trunk? That is, in the tree trunk, it travels 0.4 meters. Now, we need to calculate time. So, we have U, V, S, and a calculate time. We don't have retardation. I told one formula. Okay, what is that? S is equal to U plus V by 2 into T. Here acceleration or retardation does not require for us, even though it is an accelerated motion. Now this is equal to S, how much, Nana? 0.4 is equal to U plus V. 16 plus 0, 16 by 2 into T. This is 8. Okay, then T is equal to 0.4 by 8. Okay, how much is this? 0.4 by 8, that is 0.05 seconds. Clear? So it takes how much time? 0.05 seconds. Clear? Right. Sometimes they'll ask what is the retardation also. Okay, then how to calculate retardation? V is equal to U plus AT. From this A is equal to what? V minus U by T. Final velocity, initial velocity, and time, you know that. Then you can calculate retardation also. Or else you can use one more thing. V square minus U square is equal to 2AS also. Here VU is given, then retardation is what? V square minus U square by 2S. This formula also you can use. Right, Nana? So that's why first given data, identifying given data is most important than solving the problem. Clear? If the given data is identified, half of the problem is solved. Very good. Yeah, now see fifth question. A driver takes 0.20 seconds to apply the brakes after he sees a need for it. This is called reaction time of the driver. Okay, so this is called reaction time. Reaction time means what? For example, you are riding your bicycle or bike on the road. Okay, when you are riding, you have seen a kid is coming onto the road. Okay, you have seen that kid here, but it takes some time to react and apply the brakes. Okay, during that time your bike or cycle travels some distance. Clear, Nana? So in what time you are applying brakes after seeing the need for it? That is called reaction time. This will be different for different persons. Reaction time will be different for different persons. Understood, Nana? You are seeing the kid walking on the road here suddenly, and you apply brakes here. This time is called reaction time. During that reaction time, our vehicle will be moving. Yes or no? Very good. Now see that. If he is driving the car at a speed of 50 km per hour, means at this point, and the brakes cause a deceleration of 6 meters per second, find the distance traveled by the car after he sees the need to put the brakes on. Very good. Now at this point, he observes the need for stop. Okay, so at point B, he applies the brakes. Understood, na? So A to B and B to C. Now let us see that. So A to B, the body is traveling with uniform speed. The body is traveling with a uniform speed. B to C, the body is decelerating because brakes are applied at point B. At point A, he has seen the need. Okay, so at point B, he applies brakes. Okay, so A to B, what is the time travel? That is 0.2 seconds. Okay, now B to C, what is the deceleration? It is given that 6 meters per second square. Okay, na sir, it is given that 6 meters per second square, right? So 50 kilometer per hour is the speed of the vehicle at A. What is the speed of the vehicle at B? Same, because A to B it is traveling with uniform speed. Here the brakes are applied. So this is 54 kilometer per hour. If you convert 54 kilometer per hour into meter per second, what is the answer? 54 into 5 by 18. That is how much, sir? 15 meters per second. Okay, so at A 15 meter per second, at B also 15 meter per second. Let us take after reaching point C, its velocity becomes 0. It stops. Okay, we need to calculate this whole distance, not B to C, sir. A to C. After applying brakes means B to C. Okay, so the point after he sees the need, he sees here. Here to here we need to calculate distance. Let us take this as S1 and this as S2. Now S1 is equal to what? Speed into time. Distance equal to speed into time. Because it is moving with uniform speed, there is no acceleration. Then that is 15 into 0.2. How much, sir? This is 3 meters. Okay, so during the reaction time, the body travels 3 meters. Understood? During the reaction time of the driver, the car travels how much distance? Yes, 3 meters. Right, now S2 we need to calculate. See here S2, what data we have? U is 15 meter per second. V is 0. A is minus 6 meter per second square. And S2 we need to calculate. Which formula can I use? V square minus U square is equal to 2S. Yes or no? Right, very good. So V square minus U square is equal to 2S. V square is 0 minus U square. 15 square is 225 is equal to 2 into minus 6 into S2. Let us simplify this. How much is this? Minus 225 by minus 12 is S2. Yes or no? So if you simplify that, you will be getting S2 value as 18.75 meters. 18.75. Then what is the total distance, sir? S1 plus S2. S2 is 18.75. S1 is 3. Then how much that is? 21.75 meters. This is our answer. Got it? So be careful while solving this kind of problems. Reaction time. During the reaction time also the body travels. That distance also you need to calculate. Okay, students will calculate from this onwards. That's not. During the time of reaction also the body travels with uniform speed. Remember this point. Okay. See some interesting question. A police jeep is chasing a culprit going on a motorbike. Okay, so culprit means a thief, let us take. Okay, jeep and motorbike. The motorbike crosses a turning at a speed of 72 km per hour. Okay, the jeep follows at a speed of 90 km per hour. Right, Nana? Crossing the turning 10 seconds later than the bike. Let us see here. For example, let us take, this is the road and here is the turning. Okay, now first the motorbike is crossing the turning. It is coming here and crossing the turning at what speed? 72 km per hour. Okay, next a jeep is following this. It is bike is going. A jeep is following this and jeep also crossing this turning after 10 seconds of the bike. Understood? Means during this 10 seconds the bike have moved up to here. Then jeep is here. Clear or not? Very good. That means see the jeep is here now. Here is the bike. Okay. What is the time gap between them? 10 seconds. How much? 10 seconds. Now assuming that they travel at a constant speed, how far from the turning will the jeep catch up the bike? Let us take at this point both will catch up, bike and jeep. Okay, this point is at a distance of y from the bike and let us take x from the jeep. Then the total distance traveled by the jeep is how much? X plus y. Clear? What is the distance traveled by the bike? Y only. Clear everyone? Right. Now see from this. From this, what is the velocity of the bike is given? Velocity of the bike is given 72 km per hour. Means how much, sir, it is? 20 meters per second. Similarly, velocity of jeep is how much? 90 km per hour. How much is this? 25 meters per second. Now apply, as they both are moving with constant speeds, there is no acceleration. They are moving with constant speeds. Then speed of jeep is equal to distance by time. How much distance it has traveled? X plus y to catch up the bike by time is t. Okay, from this what can I write? 25 is equal to x plus y by t. Yes or no? Because velocity of jeep is 25. So do cross multiplication. 25t is equal to x plus y. Let us say this as equation 1. Next, coming to bike. What is the velocity of bike traveled? Velocity of bike is equal to distance by time. That is y by t. Okay, so this is 20 is equal to y by t. Then 20t is equal to y. Clear? Now you substitute this y value in this equation. Okay, no, sir? So let us see that. When you substitute that y value in this equation, what you are going to get? So that is 25t is equal to x plus 20t, because y is equal to 20t. Okay, now this is if it comes this side, 5t is equal to x. How much, Nana? 5t is equal to x. Okay, so as it is 25t minus 20t is equal to x, that is t. Okay, now this x can be calculated. How? This x can be calculated separately as x is equal to velocity of bike into t. Yes or no? Bike travels from this point to this point in time t. Then that is velocity of bike how much? 20 into t, 10 seconds. It has traveled for 10 seconds. How much is this? 200 meters. Now then substitute that value here. 5t is equal to 200 meters. Then t is equal to how much? 40 seconds you will get. T is equal to 40 seconds means total time it has taken. Now I want to calculate distance. Distance means x plus y. Okay, then x plus y is equal to 25 into 40. How much is this? 1000 meters or 1 kilometer. From jeep to this point, how much distance the jeep has to travel? 1 kilometer to catch up with the bike. Okay, this one is very important. People will forget here to solve 200 meters x value, right? Yeah. Whenever you see the question, just you pause the video and try to do it by your own. If you not get, or if you have any doubt, then you continue the video. Okay, try to do it by your own only. Whenever you are getting a doubt, then do it. See the video. Next question. Right, see this question. A car traveling at 60 km per hour overtakes another car at 42 km per hour. Here, there will be two words you will be hearing in physics. Overtakes and cross. When it is taken as overtakes. Overtakes means one vehicle is moving here. If another vehicle is coming from the back and moving ahead, this is called overtakes. Okay, what is meant by cross? Cross each other means both the vehicles should move in the opposite direction. Okay, then this is called crossing. Clear? When your vehicle is moving and moving ahead of another vehicle which is moving in the same direction, that is called overtakes. When vehicles are moving in opposite, that is called crossing each other. Remember this one. And now see here. Okay, assuming that each car to be 5 meters long, here length of the car is considered. We should not neglect the length of the car, right? Find the time taken during the overtake, and the total road distance used for the overtake. These are the two things we need to calculate. One is time, second one is the distance. Clear? Right, if you pause the video and try to solve it. Now see the solution. Let us take this is road. Okay, here is car 1 and this is car 2. This is 5 meters length and this is also 5 meters length. Both are moving in the same direction, sir. Remember that. Now car A overtakes car B. Let us see. Now the car 2 is here. Overtaking means this completely should cross the car 2. This is called overtaking position. In this way, car 1 is overtaking car 2, completely crossing it. Right, Nana? Now we need to calculate how much time it takes during the overtake and total road distance. What is the total road distance it has covered? From this point to this point. Yes or no? Total distance it has covered. Now see that. What is the distance traveled by C2 in this case? Let us take X. Okay. Then now this car, first end of the car C1, this crosses this point. Okay. Then this distance is how much? Total distance is 5 plus 5 plus X plus 5 meters. How much now total? 15 plus X. This is the distance traveled by car 1. Clear? Now distance is equal to what? Speed into time, as both are moving in the uniform, assuming that. Now distance moved by car 1, let us take distance equal to speed into time, or speed equal to distance by time. What is the speed of the car 1? Let us take V1, that is 60 km per hour. So you convert this into meter per second. 60 km per hour is 16.6 meters per second. Right? Next, what is the velocity of second car? 42 km per hour. Okay. If you convert this, what do you get? It is 11.6 meters per second. Now V1 is equal to distance by time. What is the distance? 15 plus X by, let us take time t. Okay. Now simplify this. This is 16.6 is equal to 15 plus X by t. Then I can write 16.6 into t is equal to 15 plus X. Let us say this as equation 1. Similarly, speed of car 2 is V2 is equal to, what is the distance traveled by it? How much distance it has traveled? 5 plus X. Okay, this point covers X plus 5. So that is 5 plus X by t. In the same time it also traveled. Okay. Now V2 is 11.6 is equal to 5 plus X by t. Here both the cars take same time. There is no time gap before they start. There is no time gap. So that 11.6 into t is equal to 5 plus X. These kind of problems can be solved very easily by using relative velocity concept. Okay, that concept I will explain, and I will discuss these problems also once again. When two bodies are involved, two cars, two bikes, before problems we have seen a jeep and bike, those problems can be solved easily by using relative velocity concept. In that we will discuss these also. Now substitute the value of X from this equation here. So it is 11.60 minus 5 is equal to X. Substitute this. That is 16.60 is equal to 15 plus of 11.60 minus 5. If you solve for t, you will get t value as 2 seconds. What do you get t value? 2 seconds. Clear? Na? So that is the time taken during the overtake. In 2 seconds, both the cars will overtake each other. Next, what we need to calculate? What is the total road distance it is traveled? Here to here we need to calculate. So first 15 plus X. Let us calculate X. From where you can calculate X value very easily? You can use this equation, no problem. Then x is equal to 11.6 into 2 minus 5. Okay now. So how much is this Nana x value? 18.2 meters. Okay, so 15, therefore total distance is how much? 15 plus x plus this 5 meters also. This is the total road distance they have traveled. So that is 20 plus x, therefore that is how much? 20 plus 18, so 38.2 meters is the road distance they have taken. Clear? So in this way one can solve very easily the problems. Right, next question. Yes, see our 8th question. A particle starts with an initial velocity and passes successively over the two halves of a given distance with accelerations a1 and a2 respectively. Okay now, what does it mean? It means here the body is started, okay, with some initial velocity u, clear, and it travels half of a given distances with the accelerations a1. Let us take total distance as s nana. Half of the distance traveled with an acceleration a1, remaining half travels with an acceleration a2. Here what will be the velocity? Let us take v1, and here what is the velocity? Let us take v. Okay now, because it is accelerated motion, so its velocity changes. So u to v1, v1 to v. This is, so show that the final velocity is same as, here final velocity is same as if the whole distance is covered with a uniform acceleration a1 plus a2. Means here body is moving with u and the final velocity is v. The whole the distance, yes, it is traveled with an acceleration of a1 plus a2 by 2. Then this velocity and this velocity are same. We should show it. Understood? These are the two cases. In this case and in this case, the final velocities of the body is same. Clear, sir? So in the first case, half of the distance with an acceleration a1 and remaining half with an acceleration a2. In the second case, throughout the distance it is traveling with an acceleration a1 plus a2 by 2. Then the final velocity is attained by the bodies in the both the cases are same. Let us see the proof whether it is true or not. Okay. Now see that first you apply here in the first case v1 is equal to u plus at. So v1 is equal to u plus a1 into t. But we don't have time here. So that's why you cannot use this equation. Then use v square minus u square is equal to as. Then that is v1 square minus u square is equal to 2a1 into s by 2. Okay, no. 2a1 into s by 2. Now apply for second case also. What is that? v2 square means v square minus u square means v1 square is equal to 2a2 s by 2. 2a2 s by 2. From this you can calculate v value. From this you can calculate v value. How? Let us see here. Which we can eliminate from these two. v1 square we can eliminate from these two. So that our equation will be in terms of u's and a's. So eliminate v square value, v1 square value. So from this v1 what can I write? So v1 square is equal to v square minus a2 into s. Can I write? Okay, see here. V square is equal minus v1 square equal to a2. 2 gets cancelled, nana. So v square minus v1 square is equal to a2s. From this v1 square, v square minus a2s is equal to v1 square. That is only na. Alright. Now substitute this value in this equation. What is that? v1 square minus u square is equal to this also 2 gets cancelled, then a1 into s. v1 square right here, that is v square minus a2s minus u square is equal to a1s. Clear? And now solve for v. V square is equal to a1s, here 2 is not there again, plus a2 na, a2s, okay, plus u square. Yes or no? Right. That is v square is equal to u square plus, I can write this as, if I take 2s as common, a1 plus a2 by 2. Can I write or not? As 2 gets cancelled, sa1 plus sa2. That is only na? Yes. This is the v square value, final velocity. How much? U square plus 2s into a1 plus a2 by 2. Now see here what is the final velocity value. So what is that? V square minus u square is equal to 2as formula. So that is v square minus u square is equal to 2. Acceleration is how much? a1 plus a2 by 2 into, yes. So then how much? V square is equal to u square plus 2s into a1 plus a2 by 2. Is it same or not both? Right. So the meaning of question is, if it travels half of the distance with a1 and remaining half with a distance, remaining half distance with a2, then the acceleration is same as a1 plus a2 by 2 traveling whole the distance. Clear, Nana? Next, see 9th question. Yeah, see this case. In a car race, car A takes a time t less than car B at the finishes and passes the finishing point with a speed v more than that of car B. Okay, na? So assuming that both the cars starts from rest and travels with the constant accelerations a1 and a2 respectively, then show that v is equal to root over a1 a2 into t. Okay, na? So there is a car race. For example, this is a road. This is car A and this is car B. Both are starting from the same point. This is the ending point, let us take, finishing point. Clear, Nana? Both are starting at the same time or not? See that? Both are starting at the same time. And their initial velocities are 0 because they are starting from rest. Now let car A takes t1 time, okay na, t1 time to finish the race. Then what about car B? In a race, car A takes a time t less than car B. Understood? Then t1 plus t is the time taken by car B. Got my point? You can take in another way. If car B takes something t1 time, then A takes how much time? t1 minus t time. Both are same. Here I am taking car A takes t1 time, B takes t1 plus t. Okay, how much car A takes? Less than t seconds only, na? t1 plus t minus t, then t1 seconds. Okay, both the ways. Next, let us take the velocity of the car B. Velocity of the car B is v1 at the finishing point. Okay, at the finishing point, velocity of car B I am taken as v1. What about v? Tell me. Finishing point with a speed v more than that of car B. Okay, then for A it will be how much? v1 plus v. That's it. Very simple. Okay, no. Now write equations for both the cars. So first I can write v1 is equal to u plus at. V is equal to u plus at. Can I write or not? Yeah. So v is equal to u plus at for car A. If I write, this is A, nana. Car A, I'll write v is equal to u plus at. As both the cars have 0 initial velocity, then v1 is how much? v1 plus v is equal to 0 plus a is a1 into how much time it has taken? t1. Yes or no? Then from this, what can I write? v1 plus v is equal to a1 t1. Now what about car B? For car B also you write, Nana. For car B, that is same, V is equal to U plus AT. V1 is equal to U0 AT. A is A2. How much time it has taken car B? T1 plus T. Clear? So that V1 is equal to A2 into T1 plus T. From these two equations, this is 1 and this is 2. From these two equations, what do you get? You eliminate V1 from these two equations. Eliminate V1. So in place of V1, I can write this one. So that A2 into T1 plus T, okay, no, plus V is equal to A1 into T2. Clear? Or else you can write simply V is equal to A1 T2 minus A2 into T1 plus T, you can write. This is V. This V. Okay. Now let's see, the total distance traveled by both the cars is equal. Why, sir? Because it is the race, starting point and ending point, SA and SB. So then SA is equal to SB. Distance traveled by car A and distance traveled by car B are same. Okay, if you write SA is ut plus half at square. As u is 0, I am writing half A, acceleration of first car is A1 into T1 square, time taken is 6. That is half A2 SB, how much time? T1 plus T whole square. Okay, so as distances are equal. Now you can solve for T1 from this equation. How? Half A1 T1 square is equal to half A2. This can be written as A square plus B square plus 2AB cos theta. Sorry, 2AB. T1 square plus T square plus 2T into T1. Okay, now. So if you simplify, then you will be getting T1 value as a root A2 into T by root A1 minus root A2, you will get T1 value. Right? Now substituting this T1 value in above equation, this one. In this equation, if you substitute which value? T1 value. Okay, then you will be getting result is root of A1 A2 into T. I am not simplifying this much more. Okay, simplification I am giving to you. Just I have given the idea to you how to take these first. This condition is important and these taking the quantities are important. Then using the mathematics only, simple. Clear? Yeah. Next, see 10th question. You see this question. A car starts from rest and moves with a constant acceleration. Okay, na? So you can take u is 0 and acceleration is a. The ratio of distance covered in, which is that distance covered in n seconds to distance covered in, sorry, nth second to n seconds, means s nth second to s n seconds. This is, you need to calculate ratio. Yeah, very simple. First let us calculate a distance traveled in nth second. What is the formula? U plus a into n minus half. Yes or no? That is u0 plus half into a into n minus half. Next, distance traveled in n seconds is ut plus half at square formula. Already we discussed the difference between these two. Now ut is 0, half into a into t square. T means n seconds, so n square. Then what is the ratio? A into n minus half by a n square by 2. Can I write or not? Half a n square as. Now take the LCM and see. This is a into 2n minus 1 by 2 by a n square by 2. So this is 2 gets cancelled, a gets cancelled. What is the answer? 2n minus 1 by n square. This is the ratio of nth second to n seconds. Clear? Very good. See next 11 question. So I have collected some questions. Okay, some very good model questions I have collected for your knowledge. Okay, try to practice these questions how many times you can, right? No, until you get a clarity on this, perfection on this. Now see that a train 200 meters long, means length of the train is given. How much? 200 meters. Crosses a bridge 300 meters long. There is a bridge whose length is 300 meters. Let us take this as the bridge. There is a train. It is crossing, means completely it should come out. Then only we can say that it crosses the bridge. Right now, with a speed 30 meters and leaves with a speed 50 meters. Right. When it is entering on the bridge, its speed is 30 meters. While it is leaving, its speed is 50 meters. Means it is accelerating. Yes or no? Yes. Now what you need to calculate? How much time it takes to cross the bridge. Very good. Here what is the total distance it has traveled? Length of the train plus length of the bridge. Already I said when length of the train is given, you should consider that also. Then 500 meters. Now this is the initial velocity and this is the final velocity 50 meter per second. You need to calculate time. Which formula should we use? SUVT. Very good. S is equal to U plus V by 2 into T. So if you simplify that, U plus V, 80 by 2, 40, 40 into T. Okay. S is how much? 500. So 500 by 40 is equal to T. From that, T is equal to how much, Nana? 12.5 seconds. In 12.5 seconds, it crosses the bridge. Clear? Right. Next, let us see another question. Question number 12. Yes, see this question. This is a very important one. Many times in many different competitive examinations, it was asked. So, a car accelerates from rest. Okay. Its initial velocity is 0. It is accelerating at a constant rate alpha for some time. What is its acceleration? Let us take a1 as alpha for some time. Okay, na sir? Now, after which it decelerates at a constant rate beta. From here it is decelerating at a constant rate a2 as a beta. And comes to rest. Finally, it is coming to rest. Okay, in between here its velocity is, let us take v1. So here v1 will be the maximum velocity. Already we discussed. Because from point A to B it is accelerating. Okay, and B to C it is decelerating. So v1 is the maximum velocity. This v1 we want to calculate if the total time elapsed is t. It takes a time t to move from point A to C. Okay, sir? Now let us calculate first from A to B. A to B, use V is equal to U plus AT. So V1 is equal to U0. A is alpha into, let us take time T1 here. Here take time T2, we don't know. Okay, now for part BC, V is equal to U plus AT. V is 0 is equal to U V1 minus beta T because it is deceleration. Okay, right. So that we can write V1 equal to beta T. Clear? As these two are equal, as V1 is equal to V2, one can write alpha T1 is equal to beta T. Yes or no? Yes. Now let us see that part also. Let us see. From this, alpha T1 is equal to beta T2. Beta T2. From this, one can write the relation alpha by beta is equal to T2 by T1. This is a very important relation, remember that. When the body is moving in this manner, then the ratio between their velocities is equal to inverse ratios of their time taken. Okay, remember this. This we will use in further problems. This is not required now, but for our convenience I am deriving this. Okay, now. Yeah, now from this equation I can write, from this equation T1 is equal to what can I write? V1 by alpha. Yes or no? From this equation T2 is equal to V1 by beta. Yes or no? Yeah. Now T1 plus T2 is equal to how much? T1 plus T2 is T, already given in the question. The time elapsed is T. Now from this V1 by alpha plus V1 by beta is equal to how much, Nana? T. Now you can simplify this. How? Take V1 common, it is 1 by alpha plus 1 by beta, that is equal to T. Then V1 equal to LCM is alpha beta, then alpha plus beta by alpha into beta is equal to T. So then V1 is equal to what? Alpha beta by alpha plus beta into T. This is the maximum velocity attained by the body. Remember this formula also. When situation is given in this way, directly you can use this formula if alpha 1, alpha 2 and T are known. Okay now? So V1 is equal to alpha beta by alpha plus beta into T. It looks like V is equal to U plus AT. As U is 0, it is whole is A. Means acceleration, net acceleration is how much? Alpha beta by alpha plus beta, that's all. Similarly, you can calculate total distance traveled by the body also. How? S is equal to UT plus half AT square. Yes or no? S is equal to UT plus half AT square. U is 0. In place of half, A is how much? Alpha beta by alpha plus beta into T square. This gives displacement also. Okay, now you remember these results. Alpha by beta is T2 by T1. Maximum velocity is alpha beta by alpha plus beta into T. Like V is equal to U plus AT. That's it. In place of A, this is there. A is this value. S is equal to half AT square. Okay, na? Right. Next, see another question. See this question. A particle moves for 8 seconds. Okay, na? It moves for 8 seconds is given. So here it first accelerates from rest. It is accelerating from rest and then retards to rest. Okay, similarly we have seen in the previous question, accelerating and decelerating to rest. Initial velocity is 0. This is the maximum velocity attained by the body. Here if the retardation be 3 times the acceleration, that means A2 is equal to 3 times of A1 is given. Then time for which acceleration will be, let us take this as T1 and T2. Total time is 8 seconds is given. Means T1 plus T2 is equal to 8 seconds. You need to calculate T1 value. Okay, na sir? Clear? And now here let us take this alpha beta. Then A2 by A1 is equal to what is that? 3 by 1. Previous question we have seen a relation. What is that? Alpha by beta is equal to T2 by T1. Okay na? Here beta by alpha is equal to what? T1 by T2. Okay. Then A2 by A1 is equal to, what is that, sir? A2 by A1 is T1 by T2. That is equal to 3 by 1. Right? From this what can I write? T1 is equal to 3 T2. Can I write or not? T1 is equal to 3 T2. Now substitute that. 3 T2 plus T2 is equal to 8. Therefore 4 T2 is 8. T2 is 2 seconds. Then what about T1? T1 is 6 seconds. This is our answer. Very simple. See that? Using this relation, what we have derived in the previous question. Clear? In this way it will be very easy if you derive some of the relations. See the next problem. Yeah. See this question. 14. A car accelerates from rest. It is accelerating from rest 0 at a constant rate of 2 meter per second square. 2 meter per second square for some time. Then it retards at a constant rate of 4 meter per second square. From here it is retarding at a rate of 4 meter per second square and comes to rest finally. Maximum velocity v1. If the total time for which it remains in motion is 3 seconds, then what is the total distance traveled? So this is the case we have already seen. So here, what is the net acceleration? Alpha beta by alpha plus beta. So that 4 to the 8 by 6 is the acceleration. Then s is equal to ut plus half at square. Ut plus half at square. This is 0, half a value, 8 by 6 into t square, 9. So how much, sir? 3 2 ja 3 3 ja. And now 21 by 4 meters. What is the answer? 21 by 4. Sorry, 24. So you can write that as 6 meters also. Clear? See how the problem became very simple by using this relation. Alpha is equal to, A is equal to alpha beta by alpha plus beta whenever the situation is given in this manner. Right, next see another model. See this model. A body travels 200 centimeters in the first 2 seconds. Okay, na? Next, and 220 centimeters in the next 4 seconds with deceleration. The velocity of the body at the end of the 7 seconds is what? This is the question. Now see, that means first the body travels for 2 seconds and next the body travels for 4 seconds. For 2 seconds, how much distance it traveled? 2 meters. 200 centimeters means 2 meters. Next 4 seconds, 2.2 meters it has traveled with the deceleration. Let us take that as A. Now first case I am applying. As it is initial velocity 0, let us take this as S1 and this as S2. So S1 is equal to ut plus half a t square. S1 is how much? 2 is equal to ut 0 half a. A is plus or minus? Minus. Why sir? It is deceleration. Minus a into t square. 2 square is 4. That is how much? Minus 2a. From this you will get a is equal to minus 1 meter per second square. Sorry, you should not take u0 because it is not given. Okay, you should not take u0, say u as u only. Okay, so that is s1 is ut. T is how much? 2 seconds. So 2u minus half a, we don't know, t square 4. So that is 2 is equal to, as s1 is 2, 2u minus 2a. Yes or no? So I can write 1 is equal to u plus u minus a from this. You take 2 common and cancel. So from this you can write any value, u value or a value. Okay. And now see for second case. For second case, s is equal to ut plus half a square. Which you have to take here the velocity. As it is ut plus half a square, here velocity we need to calculate and substitute. Or instead of that, you take the whole journey. Nana. For whole journey, how much time it has taken? 6 seconds. In whole journey, how much time distance it has traveled? 2 plus 2.2 means 4.2 meters. So you will get initial velocity u only. Understood? So that's why S2 you can take as how much? 4.2 meter and total time how much? 6 seconds. Now you apply S is equal to ut plus half a square. Therefore 4.2 is equal to u as u t 6u minus half a into 36. 6 square is 36. This can be written as how much, Nana? 4.2 is equal to 6u minus 18a. This is equation 2 and this is equation 1. You have 2 equations and 2 unknowns, ua. 2 equations are there. You can solve very easily. Yes or no? Alright, see that solution. So solve for these 2 equations. From equation 1 you can write A is equal to u minus 1 from this equation. Yes or no? A is equal to u minus 1. Substitute this here. So 4.2 is equal to 6u minus 18 into u minus 1. 18 into u minus 1. Then we need to solve for a value after u value. Okay. First solve for u value. What do you get from that? The value of u simply 4.2 is equal to 6u minus 18u plus 18. Yes or no? Yes. Yes, if you simplify u value you are going to get 1.15 meters per second. Okay. Now you substitute the u value in this equation so that a value you will get as that is 0.15 meters per second square. If you substitute this u value in this equation, very simple. Now we need to calculate velocity at 7th second. So v is equal to u plus at. V 7 seconds. So v is equal to u. How much we got? 1.15. Okay. Minus a value we got it. How much, Nana? What is the a value? Minus 0.15 into t 7. Okay. So you simplify this, then you will be getting 0.10 meters per second, or it can be written as 10 centimeters per second. This is the velocity of the body after 7 seconds. In this way you have to solve the problem. When this case is given, you write equations for 2, S1 and S2 you take as total, Nana. Okay, S1 is this is S1. S2 you take this one. Why I should take total, sir? Because if we write here onwards S2 value, here initial velocity you need to calculate again. Okay, so because of that we take total. So total time and total distance, you will be getting 2 equations. Solving these 2 equations you will get 2 unknowns. Clear? Very good. Next, see another problem. And yeah, let us see the 16th one. A car moving with a speed of 40 km per hour can be stopped, okay, by applying brakes after at least 2 meters. Means car is moving, here the velocity is u, here the brakes are applied so that it stops here. Okay, it travels how much distance? 2 meters. Okay, now if the same car is moving with the speed 80 km per hour, instead of 40 it is moving at 80, what is the minimum stopping distance? So first let us calculate a equation for the stopping distance. Stopping distance. Let us calculate an equation for this. For example, an object is moving. At this point its initial velocity is u. Okay, its velocity becomes 0 after applying brakes, so that after applying the brakes the car travels a distance s. So this is called a stopping distance. What do you call that as? Stopping distance. When the brakes are applied, the motion is retarded, so then acceleration is minus a. What is the acceleration? Minus a. Now let us calculate the stopping distance s. So you apply v square minus u square is equal to 2as. V square minus u square is equal to 2as. V square 0 minus u square. Here u is the which velocity? Not initial velocity. Okay, where the brakes are applied, that point. Now minus 2as. Then s is equal to, what can you write from this? S is equal to u square by 2a. This is the formula to calculate stopping distance. S is equal to u square by 2a. And now in this case, first case, okay, in this first case, what is the stopping distance is given? S1 is 2 meter. U 40 kilometer per hour. Okay, na? A we don't know. Next, in the second case, stopping distance we need to calculate. Here u, let us take this as u1. u2 is how much? 80 kilometer per hour. Here a also same, because the same car is moving with the same. Okay, na? And now use, what is the stopping distance formula? S is equal to u square by 2a. Now S1 is equal to what? U1 square by 2a. Similarly, S2 is equal to U2 square by 2a. Now you divide these two equations so that S1 by S2 is equal to U1 square by 2a by U2 square by 2a. 2a gets cancelled. Then the ratio of their stopping distances is what? No. U1 by U2 whole square. Very simple. Okay. Now U1 by U2 how much? Already it is given. U1 is 40. U2 is 80. Here you no need to convert because both are in the kilometer per hour. We are calculating ratio. That's why U1 by U2 means 40 by 80. That is 1 by 2. Okay now. Then S1 by S2 is equal to 1 by 4. Because 1 by 2 whole square. From this S2 is equal to what can I write? 4S1. Yes or no? Then S2 is 4 into S1 is how much? 2. Then what is the stopping distance? 8 meters. You remember this formula? Stopping distance formula. This is the derivation for stopping distance. What is the stopping distance? S is equal to U square by 2a. A without sign you need to substitute here because after applying the signs we got it. Okay now? So U square by 2a. This is the stopping distance. Clear? Yeah. Now see the last model in this. Yeah, now let us see. A body is moving with uniform acceleration. Okay. It crosses 2 points P and Q. It crosses 2 points P and Q with velocities v1 and v2 respectively. What is the velocity at the midpoint of PQ? Let us see. A body is moving in this way. Here is point Q, point P and Q. At P velocity is v1. At Q velocity is v2. Its acceleration is a uniform acceleration. Now I want to calculate at the midpoint. Let us take R. What is its velocity? Okay. Here PR is equal to RQ. They said that it is the midpoint. Okay, no. That means this is S and this is also S. Same distance. Now come on. It's very easy. For first part PR, I am applying equation v square minus u square is equal to 2as. Okay. So when you apply v square minus u square is equal to s for that part, v square means v square minus u square. In this case, u is initial velocity is v1. v1 square is equal to 2 into as. Okay, no? Right. Next for RQ part. Same v square means v2 square minus u square is v square is equal to 2as. You observe carefully 2as. Right hand side parts are equal. Therefore, what can we write? V square minus v1 square is equal to v2 square minus v square. We got it. Now simplify that. So we need to calculate what? V. So bring this side. V square plus v square is equal to v1 square plus v2 square. Therefore 2v square is equal to v1 square plus v2 square, or v square is equal to what can I write? v1 square plus v2 square by 2. Therefore v is equal to what? Root over v1 square plus v2 square by 2. This is the speed at the midpoint. Okay, directly you can calculate. A body is moving with a uniform acceleration. It crosses 2 points P and Q with a velocity is 3 meter per second and 4 meter per second respectively. What is the velocity at midpoint? Then root over 3 square plus 4 square by 2. You will be getting simple. Okay, no. At midpoint, this is the velocity. V is equal to root over v1 square plus v2 square by 2. Clear? In this way, you can solve numericals in the kinematics. Lot many models are there. These are the basic models repeating in the different competitive examinations. So after listening this class, you practice in books. What are the books you have? You practice lot many problems you can solve, so that you will be getting a perfection in the lesson. Okay na? Yeah, thank you very much. Please subscribe my channel and share it to your friends. Thank you very much.